Okay, so for today's review stuff, we're going to cover matrices. So we're going to be looking at some matrix stuff. We're going to define matrix addition, subtraction, and multiplication. So we're going to do that in this first part. There is no matrix division really, so we'll define plus, minus, and multiply. So first example, we're going to do matrix addition, which is really easy. If we have a matrix, so again, a matrix is just going to be a collection of numbers in kind of a rectangular format. So say I have a matrix like this. This has 2 rows and 3 columns, so it's a 2 by 3 matrix. And I want to add another matrix to it. To be able to add 2 matrices together, they have to be the same size. So this is another 2 by 3. If this one was 2 by 4, then you can't add the matrices together. If this was like a, I don't know, had another row down here and it was a 3 by 3, wouldn't add them. And the way that addition goes, it's really easy. We're going to end up with the same size matrix in our answer. And you just add the corresponding spots. So 7 is my upper left spot. I add that to the 3 that's in the second matrice's upper left spot. 7 plus 3 is 10, so that becomes my answer's upper left spot. So the lower left, 2, plus the lower left here, -5. 2 plus -5 is -3. That becomes the lower left of my answer. The upper middle is -1, plus the 6 for the upper middle there. -1 plus 6 is 5, so I put that 5 in the upper middle entry here. And then we kind of see the pattern hopefully by now. So 0 plus 1 is 1, 5 plus 4 is 9, and 1 plus 5 is 6. So that's all there is to matrix addition. Just add the pieces through. It's called coordinate-wise, is whenever the same spot on the matrices add up and you get the same spot in your answer. So matrix addition goes through coordinate-wise, and that's how it works. Matrix subtraction. Suppose we had a matrix that is 1, 4, 3, -1, 2, 0. And so that's 3 rows, 2 columns, so it's a 3 by 2. And we subtract from it a matrix that's 4, 5, 3, 1, -1, 2. So this also goes coordinate-wise, which means we take the upper left entry here, 1, and we subtract the upper left entry here, 4. 1 minus 4 is -3. That becomes the upper left entry in our answer. So as we go through and do the rest of these, we get, let's see here. We get 4 minus 5. 4 minus 5 is -1. We get 3 minus 3. 3 minus 3 is 0. We get -1 minus another 1. -1, take away 1, is -2. Then 2 minus a -1. Minus a negative is plus. So 2 minus -1 is 2 plus 1, which is 3. And 0 minus 2, 0 take away 2 is a -2. And that's how matrix subtraction works. So matrix addition and subtraction, there's not a whole lot that's complicated going on there. You just kind of add the corresponding spots in the matrices or subtract the corresponding spots and you get your answer. Next we're going to look at, there's 2 types of multiplications. We're going to look at scalar multiplication first. So this is what happens if I have a matrix, say like 7 to -3, 5. And I want to multiply that matrix by a number like 2. So scalar multiplication is what happens when you multiply a matrix by a number. And what it turns out, what happens is exactly what you'd want to have happen. You want this 2 to multiply to all the entries here and double all the entries, and that's what it would do. So 2 times 7 is 14. 2 times 2 would be a 4. 2 times -3 would be a -6, and 2 times 5 would be 10. So that's all there is to scalar multiplication. So if there was a 3 out front here, we would multiply each of these numbers by a 3. Okay, so we're going to combine a little bit of this together to make a slightly trickier problem. It's not going to be too bad at all, though. Let's say we get a matrix A equals, let's just say 2, 1, 3, 0. Matrix B equals 4, 2, 2, 1. And matrix C equals 1, 1, 3, 1. And I want to know what is 2 times matrix A minus matrix B plus 3 times matrix C. Okay, so what we're going to do here is we're going to multiply all of A's entries by 2 and write that down first. So 2 times 2 is 4, 2 times 3 is 6, 2 times 1 is 2, and 2 times 0 is 0. We're going to subtract B's entries, which are 4, 2, 2, and 1. Then we put plus 3 times C out here. So 3 times C, 3 times 1 is 3, 3 times 1 is 3, 3 times 3 is 9, and 3 times the final one up here is 3. And we're going to say this equals, okay, it's going to be 4, the upper left here, take away the upper left here 4, so 4 minus 4 is 0, 0 plus 3 is 3. Then we get 6 minus 2, 6 minus 2 is 4, 4 plus 9 is 13, 2 take away 2 is 0, 0 plus 3 is another 3, 0 minus 1 is negative 1, negative 1 plus 3 is 2. And we get our answer matrix there. Okay, so addition, subtraction, and little combinations like this hopefully are not too bad, and that's a couple examples how they work. To finish up, we're going to look at the other type of multiplication that you can do with matrices, which is called matrix multiplication. So this is what happens when you multiply a matrix by another matrix. So let's say we got the matrix 2, 1, 3, 0, 1, 4, and we're trying to multiply that by the matrix 3, 1, 2, negative 1, negative 2, positive 1. Okay, so how to tell when you can do a matrix multiplication. This is a 2 by 3 matrix. So if we write the size of the left-hand matrix down, and then the right-hand matrix, we write its size down, which is 3 by 2. If the middle numbers match, then you can do the multiplication. So there's three columns on this. That means that we need to have 3 rows on this to be able to do the multiplication. 2 by 2 from the outer numbers tells you what the product size will be. So after we do the multiplication, we'll end up with the 2 by 2 matrix. So how this works is a bit different. We take the first column here, we're going to tilt it, and we're going to kind of keep track of its numbers above the numbers here. What we're going to do is we're going to multiply each of the top entries here by the numbers above them. So 3 times 2, or I guess we say 2 times 3. We're going to add it. 1 times 1 is 1 times 1 plus 3 times 2. So I took the first column here and I tilted it and I hit the top column there, or the top row there. So first column, top row. In my answer, that gives me the first column, top row in my answer. So then I take these numbers here and I hit the bottom entries. So that's first column, bottom row. That's going to generate the first column, bottom row. 3 times 0 is or I guess we'd say 0 times 3 is our first entry, plus 1 times 1, plus 4 times 2. So now we're done using the 3, 1, 2, And so now we're going to go and tilt the second column. -1, -2, +1. That's going to hit the top entries and the bottom entries, so that will create the top entries and the bottom entries here. So 2 times -1 plus 1 times -2 plus 3 times 1. Then down here we'll get 0 times -1 plus 1 times -2 plus 4 times 1. Okay, so we total these all up now. This is 6 plus 1 plus 6 for the top entry. The first column bottom entry is 0 plus 1 plus 8. The upper right entry is -2 plus -2 plus 3. And the bottom entry is, see, 0 times -1 is 0 plus 1 times -2 is -2 plus 4 times 1 is 4. And then I'm going to add these all up. So 6 plus 1 plus 6 is 13. 0 plus 1 plus 8 is 9. -2 plus -2 is -4. Plus 3 is -1. 0 minus 2 is -2. Plus 4 is +2. And this is our answer. And we saw from what we did up here, the answer was going to be 2 by 2. So that's one example of matrix multiplication. We're going to make up a second one, and we'll have you all try it. And so we'll have you all pause the video, give it a try, and then I'll work it out with you, and you can check and see if you're getting stuff right or if things are matching up weird. So suppose we had this matrix, and we're trying to multiply it by the single matrix, or the single column matrix. 2, 1, 4 for the first column, and actually I guess we'll put a second column in there. 1, -1, 3. So we want to try to do this multiplication. So if you guys want to, you could pause the video here and see if you can work that multiplication out, and then unpause it, and you can check your work here. All right, so I'm going to assume you paused it and tried it. Let's work through and see what we should have done. So take the first column, we'll tilt it 2, 1, 4. I'm going to go through, and now that I got 3 entries here, a couple things I should do before I get started. This is a 3 by 3. This is a 3 by 2. The middle numbers match, and we're going to get a 3 by 2 matrix back from our answer eventually. So. Okay, take the first column, we tilt it, we hit the top entries, and I'm going to kind of do these multiplications as I go. So 2 times 2 is 4, plus 1 times 1 is 1, plus 4 times 3 is 12. That's my upper left entry. Then I hit the middle with it. 2 times 3 is 6, plus 1 times 2 is 2, plus 4 times nothing is nothing. Then I get the bottom entries. 2 times -1 is a -2, plus 1 times a -4 is a -4, plus 4 times 1 is +4. Okay, we're done using that first column, so scribble it out. And then we're going to tilt the second column, 1, -1, and 3. So when we do that, that's going to get us the top, middle, and bottom entries here, and then we just add them all up. 1 times 2 is 2, plus -1 times 1 is -1, plus 3 times 3 is 9. 1 times 3 is 3, plus -1 times 2 is -2, plus 3 times 0 is 0. And then we get, let's see, what is it? 1 times -1 is -1, plus -1 times -4 is +4, plus 3 times 1 is 3. So now we're going to add all this stuff up. 4 plus 1 is 5. 5 plus 12 is 17. 6 plus 2 is 8. Plus nothing is still 8. -2 plus -4 is -6. -6 plus 4 is a -2. Okay, 2, take away 1 is 1. 1 plus 9 is a 10. 3, take away 2 is 1. 1 plus nothing is 1. Negative 4, or negative 1 plus 4 is 3. 3 plus 3 is 6. Okay, so that is our answer there. I think while we're at it, we're just gonna go and do the last two topics that I wanted to do in this video, and then we'll just stop it and post this video here, and I think that'll do it for our review stuff. So that's a little bit about matrix addition, subtraction, multiplication. We're going to look at a matrix operation called determinant. So if you see what looks like a matrix written in an absolute value, and we're going to look at a 2 by 2, 3 by 3, and we'll try a 4 by 4 also. So for a 2 by 2 determinant, you write the matrix in what looks like absolute value. This is going to be real easy to calculate. All you do is you multiply these two together, and you get your number there. So 3 times negative 2 is negative 6. You multiply these two numbers together, but you're going to have to switch the sign before you record it. So when you multiply these two numbers together, you would get positive 4, but you switch the sign and you put a negative 4. And then you add these two together. Negative 4 plus negative 6 is negative 10. And that's how we calculate a 2 by 2 determinant. So I'm going to make, this is the 2 by 2 process. I'm going to make a 3 by 3, and then we'll make up 2 of them where you all try to work them and pause them. And then we'll move on to 4 by 4, which is kind of its own deal. So let's say we had 1, 2, 1, 3, 2, negative 2, negative 1, negative 1, positive 1. So now we want to find this 3 by 3 determinant. The process we do is going to be kind of similar to this, although there's a couple extra steps to it. So step 1, we recopy the first 2 columns. We will have 3 top to bottom numbers that will multiply together. And these 3 top to bottom numbers, we do not switch the signs on what they end up being. So 1 times 2 times 1 is 2. 3 times negative 1 times positive 1 is negative 3. Negative 1 times 2 times negative 1 would be positive 4. So I'm going to write those numbers out. It's 2 plus negative 3 plus 4. Then we have 3 bottom to top multiplications. Except on these 3 bottom to top multiplications, just like with the 2 by 2 case, we have to switch the sign before we record it. So 1 times 2 times negative 1 would be a negative 2. Switch the sign, record a positive 2. Negative 2 times negative 1 times 1 is positive 2. Switch and record a negative 2. 1 times 2 times 3 would be 6. Switch and record a negative 6. So then these 3 numbers, we're going to add them on in as well. And now we just got to add all 6 of these numbers together, and that will be our 3 by 3 determinant. So let's see here. 2, take away 2 is nothing. Nothing minus 6 is negative 6. Negative 6 plus 2 is negative 4. Negative 4 take away 3 is negative 7. Negative 7 plus 4 goes back to negative. Negative 7 plus 4 goes to negative 3. Okay, so that is how to find a 2 by 2 and a 3 by 3 determinant. So I'm going to make 2 of them up for you all to try using that same process, and we'll have you all pause the video, and then I'll work it through, and you guys can check your work against it. See if you're getting the same thing. All right, so with these 2, try to calculate these 2 determinants. So I'd pause the video here to try to work those through, see what you come up with. And so what you should have done is multiply these 2 together. We would get a 5. These 2 together multiply together to be 21, but that's a bottom to top one, so we record a negative 21. You add them up. Negative 21 plus 5 would be negative 16. All right, on this 3 by 3, we recopy the first two columns. So let's write a little switch sign. I'll put that there still just to remind y'all. All right, so we're going to have 3 top to bottom multiplications. Don't switch the signs on these. 1 times 1 times 4 is 4. 2 times 1 times 2 is 4. Negative 1 times 3 times 2 is negative 6. So we get a 4 plus a 4 plus a negative 6. Then we do the 3 bottom to top ones. We do need to switch the signs on these before we record them. So we'll say switch sign. Say that's going to be a negative 2, so I switch and record a positive 2. That's a positive 2, so I switch and record a negative 2. This is a 24, so I switch and record a negative 24. So we get 2 plus negative 2 plus negative 24. And let's see here. Okay. 2 plus negative 2 is nothing. Take away 24 is still negative 24. Negative 24 plus 4 is negative 20. Negative 20 plus another 4 is negative 16. And then we get negative 16, take away another 6. So negative 16 take away 6 should be negative 22. Okay, so that is a couple examples of 2 by 2 and 3 by 3 determinants. To finish up, we're going to look at what's a 4 by 4 determinant. And we're going to have to do what's called a minor and cofactor expansion. So to find the minor of a matrix, say we had a matrix like this 1, 3, 4, 1, 2, 1, 3, 1, 0. And we're told to find the minor, let's say 1, 3. What this does is say, get rid of the first row, so pretend that the first row is gone. Get rid of the third column, so pretend the third column is gone. And then take the determinant of the leftovers. So if we had a second matrix, say like a 2, 1, 4, 1, 3, 1, 6, 1, 2. And so, yeah, you just do the little cross thingy here to get that. Excuse me. Let's say we got a second matrix here and we're asked to find what's M22. So this says second row is gone, second column is gone. These 4 corner pieces, you'll push them together and leave them in the same configuration they were in, and it'll form the determinant of that. So that's how to find a minor. We get this thing, it's a cofactor, which is aij equals negative 1 to the I plus j power times the minor ij. So this is the cofactor equation, and we're going to do what's called a minor and cofactor expansion to solve a 4 by 4 determinant. So let's say we were asked to find the determinant of a 4 by 4 matrix 1, 2, 1, 3, 0, 1, negative 2, 1, 4, 0, 2, 0, 2, 1, 3, 1. And the first thing you want to do is identify the row or the column that has the most zeros in it. So in our case, it's going to be the third column. So we're going to write out a cofactor expansion of the third column. So I write the number, the top number in the third column is 4. I put an A. I put 4 as row number, which is row 1. Then I put its column number, which is column 3. Then I get plus 0 times A row 2 column 3, so that's A23, plus 2 times A row 3 column 3, plus 0 times A, that's row 4 column 3. 0 times anything is 0, so we don't have to calculate the cofactors on these two. So we're down to just saying we get 4 times A 1, 3 plus 2 times A 3, 3. So we're going to do scratch work to find A13. And we're going to do scratch work to find A33. Okay, so to find A13 is -1 times I plus j. I is 1 plus j is 3 times the minor I is 1, j is 3. So that's from that cofactor equation. This is -1 to the 4th power because 1 plus 3 is 4. -1 to the 4th power is really +1. So we get +1 times M13, which is just equal to M13. So for this particular case, A13 is the same as M13. So now what M13 says to do is mark out the first row and the third column in our matrix. So we're going to pretend that the first row and the third column are gone. And we're going to form the matrix with the remaining parts. I'm still going to need to use this matrix again, so I'm not going to actually mark them out, but we're just going to pretend like those numbers are gone, and we'll have a determinant of the leftovers. So first row, third column gone, so we get 2, 1, 3 is left down here. 1, -2, 1 is left there. See, first row gone, third column gone, 1, 3, 1 is here. So now we want to calculate what is this 3 by 3 determinant. So we recopy the first column, recopy the second column, get our 3 top to bottom multiplications. So that's going to give me -4, 9, and 1. Get our 3 bottom to top ones that I have to flip the signs on before I record them. See, that's a -6, so I record a +6. This is a +6, so I record a -6. And this is a +1, so I record a -1. And if you look at this, 6 plus -6 will cancel. 1 plus -1 will add up to nothing. -4 plus 9 is 5. So A13 is equal to 5. So A13, we can replace it with 5. Now we need to calculate A33. So I'm going to use a different color for that. So we'll say, all right, A33. This is going to say cross out the third. This is the last calculation. I can actually cross these out. So third row's gone, third column's gone. I'm going to form a determinant of the leftovers. So 1, 2, 0, 1 is the upper rectangle kind of. So we got 1, 2, 0, 1. 3, 1 down here. Then out here we got 2, 1, 1. So y'all look at that again for a minute, just so. It's this rectangle with these 2 below it, and then 2, 1, and 1. All right, so I recopy my first 2 columns. And we're going to go through and do 3 top to bottom multiplications. We don't switch signs on these. So that's 1, that's 0, that's 4. Got 3 bottom to tops. We do switch signs on these before we record them. So this will be 6, so it's -6. That's 1, so it's -1. That's 0. -0 is the same as 0, so we don't actually need to write 0 in. -1 plus +1 cancel. -6 plus 4 is -2. So A33 is equal to -2. So I can put a -2 here. Then our determinant, finish it up, this is going to be 20 plus -4. So 20 plus -4 is 16. And that would be our 4 by 4 determinant. So we'll stop there and say that that's enough stuff. Okay, and then next class period, the 20th, we'll be over in NCTC's Canvas, and we'll be starting the course off there. All right, so stop this here.